Welcome to this video about bipolar stepper valves. We are going to look at the ICM and ICAD from Danfoss. The valve consists of a body on a head, which can be opened manually with a magnetic tool. It takes 2.5 turns to open it completely. When you dismantle the valve head, you will find a part that is used to seal the valve when it's closed. The mobile part goes up and down on an onlay screw that is connected to the valve head with magnets. There is a pin that prevents the mobile part from turning on itself. Here we have the hand tool with 16 small magnets. Now we are going to look at the ICAD, the stepper valve motor. When we dismantle the top part, we find the driver that drives the motor. It has 3 buttons, a liquid crystal display and 2 electronic cards. At the back of the stepper motor there are 2 connectors, one for the 24-volt DC power supply and the other for the driver's analog and digital inputs and outputs. In the lower part of the ICAD, we find the stepper motor. On the nameplate, it indicates 1.8 degrees, which is the angle when the motor moves the step. At the top of the motor shaft, you can see the position feedback disc. On this disc, we can see 200 lines, which correspond to the number of steps. Therefore, 200 multiplied by 1.8 equals 360 degrees. This means 200 steps is one full rotation of the stepper motor. The motor shaft is fixed on the valve head. The magnetic part of the stepper motor is identical to the magnetic end tool. This is our rotor, composed of 2 magnets. Each one is made up of many teeth. To be able to count the teeth easily, we will put ink on the rotor to print the teeth on a sheet of paper. We can see that the teeth are offset by 1 notch between the 2 magnets, and we have 50 teeth per rotor. The rotor is made up of 2 magnets whose polarity is reversed. On the stator there are 6 teeth on each stator winding. 6 teeth times 8 coil equals 48 teeth. We are going to look at the stator of the stepper motor. We have 4 wires connected to the driver. We have placed small wire extensions here to facilitate the tests. Using our breadboard, we are going to fix our extension to test the ohmic resistance of the winding. There is no continuity, so we have to invert 2 wires. We find a first coil, then a second, with a resistance of about 20 ohms per coil. We will now test the stator windings inside the motor, which are magnetized when we power the coils. We have 4 poles for the first coil and 4 more for the second. We now understand the different parts of the stepper motor. With a 9-volt battery, we will make the motor turn. When we supply power to coil 1, the motor turns in one direction. It turns in the opposite direction when you supply power to coil 2. To reverse the direction of rotation, simply invert the wires connected to coil 2. Now we can see that the motor rotates in one direction. The powering sequence of the bipolar motor is composed of 4 actions. First, coil 1 is powered with the positive of the battery on the green wire. Second, coil 2 is powered with the positive on the red wire. Third is to inverse the polarity, so coil 1 is powered with the negative on the green wire. Finally, the red wire of coil 2 is powered with the negative on the battery. Each action corresponds to the movement of one step of the motor. We can now reassemble the driver on the feedback disc on the motor. The ICAD is driven by a 4 to 20 mA signal. We have previously indicated by the controller that the valve is an ICM 25. That means the motor has to do 2.5 turns of 500 steps to open it. When we send 4 mA, we see that the motor indicates 0% of opening. It is necessary to increase the signal by 16 mA to open the valve to 100%. That's to say, an increase of 1.6 mA opens 10%. If you check the consistency between the opening percentage and the position of the valve, we can see that the motor does 2.5 turns to open the valve. When the stepper motor indicates 0%, it's clear that the valve has reached its closed position. In order to visualize the electrical impulses sent to the bipolar stepper motor, we will connect an oscilloscope to the 4 wires of the 2 coils. We can see that the 2 coils are permanently powered in order to block the rotation of the motor. When we modify the position set point of the valve with the signal generator, we can see the electrical impulses sent to the stepper motor. If we zoom in on the oscilloscope, we see the sequence which corresponds to the 4 actions of the motor supply. The only difference is that there is an overlap, a half step supplying the coils. Therefore, there is a constant power to maintain its position with sufficient torque to prevent it from moving. Thank you for watching this video and see you soon for new adventures.